everybody. Let's do solutions to problem set 2. The first problem is about using a for loop to reduce the number of lines. And so I notice I'm starting at 30, adding numbers in increments of 10, going up to 140. And so that's 12 total repetitions. So one thing you could do is you could write a loop. Here, let's do problem 1. So that way we'll have a complete solution set. Okay, problem 1. So one thing you could do, let's start by defining the array list for integers. Remember, you can't do an array list for a primitive type like int. So array list of integer called list, new array list tab. So I could loop 12 times. 0 up to 12 will repeat the part in the body 12 times. And then I can have a separate variable for the value, which will start at 30. And then I'll say list.add the value. And then I want to add 10 to the value each time. So plus equals means value equals value plus 10. This is the same as val equals val plus 10. So this should work. Let's just make sure it works at the end by displaying what's inside the list. And we'll see what it looks like. Okay, so I've got 30 up to 140. So I see that that's worked. A more direct thing you could do is, instead of figuring out you want to loop 12 times and having a separate variable, let's just have the loop variable take on the exact values we want. So we'll go up to 140. So we'll start at 30 here, and we'll go up to and including 140. And then instead of adding 1 every time, we'll add 10 every time. And now I can just say list.addValue. We can run that and see if that does the same thing, which it should when I add the semicolon here. Okay, and indeed it does. So I think this is probably a more direct approach for this problem, but it's good to be familiar with both approaches. All right, let's do problem 2. Write a loop to calculate and display the sum of all even numbers from 110 to 9984. All right, let's do problem 2. Alt enter. Okay, so I want to add a whole bunch of numbers. So let's visit the numbers first. So I want all even numbers, what I say, starting at 110 and going up to 9984. So to me, this is the most direct way to visit all the even numbers. We start at 110, which is an even number. When you add 2, that gets you to the next even number, and you go all the way up to here. We'll take a look at some alternate solutions in just a second, but I think this is my favorite. I'll have a sum that starts at 0, and then inside every loop, I will add in the next number. So each time I loop, I'll add a new number to the sum, and at the end, we can print out what the sum is. So let's see what it looks like. All right, great. Here, I'm going to comment out problem 1 so it doesn't display that answer anymore. Okay, it looks good. If you got to the problem set early, or if you opened the problem set early, then the problem looked slightly different. I think I had an extra 9 here, so you were adding way more numbers, and let's see what that looks like. So here, my sum ends up negative, and a lot of people felt a little bit upset about that. So when I made up this problem, I didn't realize that I would overflow the int so soon. And that's what's happening here. I'm overflowing the int. And what that means is that the int variable only has a fixed amount of memory it uses to store values. And so what that means is that there is a maximum value that integers can hold. And I can tell you what it is. It is integer, dot max value. So we're going to print out the max value. So here's the maximum value an integer can hold. And this is actually 2 to the 31st power minus 1. Because integers use 32 bits to store their data. The problem is the sum that we're trying to calculate is larger than that. And so what happened was when we added numbers in, we ended up with a number that was larger than the integer can hold. And because of how integers specifically represent negative numbers, when you reach the maximum value and then you add 1, the value flips around to be negative. And so that's how we entered the negatives. A solution to this, well, my solution to this was to give you a smaller problem. But this is not actually a very large number. So it's pretty frequent to want to do something with larger numbers. So you can replace the variable with the data type long. Long is just a longer integer. So it still holds integer values, only this data type uses 64 bits to store the data rather than 32. And so I can tell you what its maximum value is. So this is the maximum value that long can store. And now you'll notice that I kept printing the sum, and now the sum represents just fine. If you know for a fact that you don't need very large numbers, you could use the short data type. Short only uses 16 bits. And its maximum value is 32,767. And this is very misleading because this looks like it worked, but the answer is completely wrong because notice I haven't been changing this sum at all. So what's happened here is short is so short that we've gone into the negatives and back into the positives, and then back into the negatives and then back into the positives a few times. So the sum really isn't 31,000. It's something much, much larger, but we overflowed the short a whole bunch of times. Anyway, let's go back now and look at some other things you could have done here. So instead of adding by 2's, you could have done something like this. You could have said val equals 110, and you could leave this off entirely, and you could say val is less than or equal to this, and val plus equals 2. A different thing you could do, and then you'd add val. So it actually is allowed to leave out certain parts of the for loop, because the for loop data structure is just there to execute certain statements in a certain order. So it executes the initializer, and then the check, and if the check is true, it runs the body, and then the updater, and then the check, and so on. A different thing we could have done is, if you'd figured out that the loop has to loop exactly 55 times, you could start at 110, you could add in the val, and then you could say val equals val plus 2. I think this is a much worse solution than just visiting the numbers that we want to add directly, but this is a possible solution. Another solution that I think is less good would be this. We could say, let's start at 110, go up to, I forget what it was now. Oh, sorry, we didn't want to loop 55 times. Sorry, this would be the solution I was trying to do, because we wanted to go up to that very large number. So what I did to do the computation is I said we wanted to end at 9,984. We're starting at 110. So let's take the difference between those numbers and divide it by 2, since we're only visiting even numbers in that interval. And that gives us 4,937 loops. So like I said, anyway, that would work, but it is a less good approach in my opinion. The last thing we could do is let's start at 110. There's never a last thing. You could always make up more things. But we'll start at 110. We'll say, let's go all the way up to 9,984. But let's just increase our counter by 1, and then we say if I modulo 2 equals 0. So if you remember from before, this is how you can test to see is your number even. Start this at 110. In that case, we'll do sum plus equals I. So here we're looping through all the numbers, but we're only adding the even ones. This works also, but I think that this one's less good because it seems a little bit wasteful of execution time to visit a bunch of values that we don't actually care about. So rather than visiting a whole bunch of values and testing for the good ones, let's only visit the values that we care about and add all of them in. Okay, let's do problem 3. Okay, so each of these go wrong somehow. What's going wrong? So let's, it's been a couple weeks since I've written this and I haven't looked at it. This is live, so let me look at it the way that I would, fresh. So here I know that we're saying I starts out at 0, and then the very first thing that happens is we ask, is I greater than 100? And the answer is no, because we've initialized it to 0. So because the answer is no, we don't execute the loop body even once. We exit. We go straight to the closing parenthesis, the closing brace for the block, and we keep executing whatever code would happen underneath. So in this first one, what will happen is nothing. It does not print anything. Okay, let's look at this one. Here we are initializing I to be 100. We ask immediately, is I larger than 0? And the answer is yes, because we initialized it to be 100. So we print 100. And now we add. So now I is 101. And we ask, is it larger than 0? And the answer is yes. So we print 101. And then we add. And then it's 102, which is still larger than 0. So we print 102. And hopefully you can see that that will just keep going forever. Except for the fact that ints overflow. So it won't really go forever. But even though in actual reality this is not an infinite loop, I think a lot of programmers would still call this an infinite loop. We're just going to print from 100 all the way up to the maximum value of int. And then it will eventually stop. Okay, let's do problem 4. The mod operator. Oh, I forgot in my other example you didn't know about the mod operator yet. Well, you will by the time you watch these solutions. Okay, so you can use the mod operator to test for divisibility. Here's the problem. We're going to display numbers that go from 20 up to 100, displaying a star before the number if it's even. The word high after the number if it's divisible by 3. But if it's both, then we'll display the word wonk instead of anything at all. All right, so let's do it. So problem 4. Oops. So what did I say? I wanted to display numbers from 20 up to 100. So up to and including 100. So let's just do that much. And let's just test it. So during the year, I'll tell you about a short build test cycle. And that's what this is. So now I'm just verifying, am I printing numbers starting at 20 and ending at 100? And the answer is yes. And now I can go in and start adding the other bits. So what were the conditions? So I'm going to do it wrong first, and then we're going to fix it. If I just go through kind of sentence by sentence, you'll see what goes wrong. So there's 3 things I want to test for. I want to test if a number is even. So if I is divisible by 2, this is saying if the remainder when you would divide it by 2 is equal to 0, that means it's divisible by 2, and that means that it's even. So in the case that it's even, I want to, let's display the full thing. So I'll display a star followed by I. And if a number is divisible by 3, I'll have the word high after it. So if when I divide it by 3 the remainder is 0, that means it's divisible by 3. So I'll display I followed by high. If it's both, so if I mod 2 is 0, and also I mod 3 is 0, in that case, we will print the capital word wonk. Oops. Holy gazebo. All right. So far, so good. Where's my problem? Here it is. And then let's just print out I. So like I said, I'm doing this wrong on purpose. But if I were a beginning programmer, I would think, okay, let's test the first condition. And now let's test the second condition. And now let's test the third condition. And if it's none of those 3, we'll have an else statement to print. So let's see what this actually prints. Let's go all the way to the beginning. All right, so star 20 is correct, but then it prints 20 again, so that seems wrong. And then 21 high is correct, although I guess I should have put a space in here. And then it just prints regular 21. And so that's not correct. Star 22 is correct, but then it prints regular 22, which is not right. 23 is right. It should not print star 24 or 24 high. It should only print wonk. So it's printed all three of them because 24 is divisible by 2 and 3. So what's happened is so let's imagine when I is 24. The first if statement was true, so we did the first one. The second if statement was true, so we did the second one. And then they were both true, and so we did the third one. But in the problem specification, it said that if both were true, then we only want to do the first one, then we only want to do wonk, not the first or the second. Let's try and fix it in a way that's not going to work. You might think, well, let's use an else if chain because we only want one of these things to be true per loop. So either we're going to do this one, or we're going to do this one, or we're going to do that one. But we'd never want to do like star number and then later on do wonk for the same number. So an else if chain is a great way to make sure that only one of your if statements will ever execute. The body for one of your if statements will ever execute. But this still doesn't really do what we want because you'll notice that now wonk, I'm just scrolling down here, wonk never displays. And hopefully it's intuitive why. Wonk will never display because if a number was divisible by 2, we would have done an earlier statement. And if it were divisible by 3, we would have done an earlier statement. And so we'll never even get to the test that asks, is it both? It will never be both. Or rather, we'll get to the statement, but it will never be true that both are true, because if either one of them had been true, we would have done an earlier statement. All right, so let's reorder them. Let's start with this one. So let's start with the test for both. So if it's both, then we'll do wonk. If it's not both, then we'll say, is it even only? And in that case, we do star. If it's not both and it's not even, then we'll ask if it's divisible by 3, and we'll do the divisibility by 3 test only. And then if it's none of those, then we'll print out the number by itself. And so this ordering with an if-else statement, I think, will finally do the right job. And we can double check it. Yes, so this looks like what we want. So that would be the final solution. And the lesson here is, there were two lessons. One lesson was to think about how to use the mod operator to test for divisibility. But the other was, you have to kind of think carefully about the sequence that you're doing things in. If you just wrote it in the order that I'd given you the problem specification, it wasn't going to work. And you would have had to think through, why is that? And then what do you actually want to be testing first, and what do you want to be testing second? All right, let's keep going. All right, problem 5. Let's think through this common mistake. So the double pipe symbol here is how we say or. This double ampersand is how we say and. Let's say that I want to do something. I want to test to see whether a user number isn't 1 or isn't 2. So I want to do something if the user didn't type 1 or 2. If I was going to translate this English sentence directly into code wrongly, I would say, okay, I want to do something if usernum isn't 1 or usernum isn't 2. That's when I want to do a thing. And so the question is, why doesn't that work? So I've written some other code here. Here I'm looping 10 times, and I'm generating some random numbers. And I'm going to print each number, and then I'm going to do the test that doesn't work. I'm going to test if it's not 1 or 2. And if it's not 1 or 2, I'm going to print out it's not 1 or 2. And so let me run it. Oops, I accidentally ran it in debug mode, but that's okay. So right away, we can see that it's not working. The user number is 1, but then it says that it's not 1 or 2. When it's 5, it says that it's not 1 or 2, and that should be correct. I never generate 2. But it, you can see that it's just doing it every single time, no matter what. So what's going on here? Let's set the user number to be 1 on purpose, and then ask ourselves what's happening. So here, I'm going to pause it here. So we're going to run the code, So the code is running, but it's paused right now. User number equals 1, we can see. So I'm going to print that out. So let's evaluate an expression. So right now I want to say, is it true that user num doesn't equal 1? And you should think right now. Think about what user number is. Is it true or false that user num not equal to 1? And the answer is false, because user number is 1. 1 not equal to 1 is false. Okay, and that's correct. So now let's think about the next one. Is it true that user num isn't equal to 2? The answer there is true, as you can see there. But now let's think about what happens when you put them together. This first thing was false. The second thing was true. The way OR works is OR will return true if either one of the two things is true, or if they're both true. So if we have false or true, that whole thing is evaluated to true, and so now we say, oh, it's not 1 or it's not 2. Because even though it was 2, wait, what am I saying? So even though it was 1, it was true that it's not 2, and so if I ask, is it true that it's not 1 or it's not 2? Well, yeah, it's not 2, so that whole thing is true. So that's the way OR works in Java. It's a logical OR, but sometimes it works a little bit differently than you might think about OR in English. So what you want to think about is when you see OR, pronounce it this way. Is it true that user num isn't 1? Is it true either that user num isn't 1 or that user num isn't 2? And if you pronounce it that way, then the answer is clearly yes. It is true that either it's not 1 or it's not 2, because that has to be true all the time. Okay, so what are we really trying to say? If we want to fix this, let's go back. We wanted to say that, we wanted to say, so in English what we said is we wanted to test if the user num isn't 1 or isn't 2. Logically speaking, what we really want to know is it true that the user didn't type 1 and also that they didn't type 2? So let's look at that one more time. In text it says, I want to do something if the user didn't type 1 or 2. But what we mean is that we'd want to do it if they didn't type 1 and also they didn't type 2. So only if they didn't type either one of those together do we want to do it. And so that's why you use logical AND, because logical AND is only true if they didn't type 1 and also they didn't type 2. So let's run this again and now verify that this does what we want it to do. So here, so 5 isn't 1 or 2, but then by the time I get to 2, oh, I don't have, okay, hold on. Let's do this. Okay. Let's run it one more time. Okay, so you can see that when num is 3 and 0 and 4, it's not 1 or 2. But if it's 1, we don't print that. And if it's 2, we don't print that. And so that's working. Now we are successfully doing the test. Okay, so this is a little bit tricky. I'm going to say it one more time just to be absolutely sure. When you're using ands and ors, don't just translate it in your mind. You have to think that something or something will, here, don't autocomplete. Something or something is true if either side is true, and something and something is true if both are true. And so, you can for sure write an if statement based on your intuition the first time, but go back and think through carefully. Think, what will happen if the first one is true? What will happen if the second one is true? What will happen if only one of them is true? Like, think through all the particular cases and make sure it's actually going to do what you want it to do. All right, let's keep going. Now part C, Right, so in Python, you can do this kind of double comparison. In Java, you can't do this. We're actually making two separate statements. We're saying it has to be true that num is greater than 10 is the first half, and the second half is num has to be smaller than 20. So in Java, the way you do this, I'm just going to gut the inside of problem 5. You would say something, so let's do num equals 3. We would say if 10 is less than num, and also num is less than 20. Because it makes sense that if num were going to be inside this interval, both would have to be true at the same time. Num would have to be larger than 10, and also num would have to be less than 20. The reason it's highlighting here is because num is 3, and so this is always false. But if num were not a fixed number, then it wouldn't highlight. All right. What's next? 6. Okay. All right, so in 6, I have these kind of nested if statements and the if else statements. And then on the right-hand side, I have code that I'm claiming is the same. First, let's think about why it would be the same. So what about this A? I might ask, under what conditions would A get printed? And because A is inside this if statement, and it's also inside this if statement, I know that both of these would have had to be true in order to get to this third line of code. So in order to print A, I know that A has to be larger than 0, and that B has to be less than A. And that's what I've written here. If A is greater than 0, and also B is smaller than A, that's the exact scenario under which I would print A. Okay, but what about this one? This one is a little bit different. Because if I was going to use the same kind of logic, I'd say, all right, if I was running the code one line at a time, in order to get to B, I know A has to be larger than 0, because if it weren't, I would have skipped this entire block of code. And I also know that B would have to be 8. But in my answer here, I have an extra piece. I'm not just saying A larger than 0 and B equals 8. I have this thing. I'm saying it's not true that B is less than A. Because remember, the exclamation mark means logical negation. It means that the thing that comes after it is not true. And the reason why is because this is an if-else chain. So if I'd just left it like this, let's cut this part out. So let's imagine A is 10 and B is 8. If A is 10 and B is 8, on this side we think we should be printing B, because A is larger than 0 and B is 8. Okay, let's look on this side. If A is 10 and B is 8, A is larger than 0, so that's okay. But B is less than A, because B is 8 and A is 10. And so this would be true. And so I'd actually print A. And then because I printed A, because this statement was true, I never visit the else condition, and so I never even check this condition. So that's why this isn't the same on the right-hand side. It's absolutely true that in order to print B, A has to be larger than 0 and B has to be 8. But there's an additional situation, which is the earlier if statement can't have been true. And that's why I put this in. Because if the earlier if statement were true, I wouldn't even get that far. So I took the earlier if statement and I said it also has to be the case that it is not true that the earlier if statement would have happened. And that's what led to the B. The same idea applies to the C. In order to get to C, A has to be larger than 0. But it also has to be the case that B is not less than A, and it has to be the case that B wasn't equal to 8. So here I said A greater than 0, not true that B less than A, not true that B equals 8. By the way, it's you would never actually see a programmer do this. This is technically correct, but it's a little bit silly. Instead of saying not true that B equals 8, you would just say B not equal to 8, like this. But the reason I wrote it this way was to sort of emphasize that I'm negating a previous condition. Okay, what about D? Well, D will print no matter what as long as we're inside the first if statement. So as long as A greater than 0, we'll just display D. And then E only happens if the initial if statement is false. So I could have written it this way. I could have written it, if it's not true that a is larger than 0. But here I've chosen to ask myself, logically speaking, if it's not true that a is larger than 0, then what is true? Well, if it's not larger, then it has to be less than or equal. And so that's why I wrote that condition that way. All right, so rewrite the code below as a series of individual if statements that will be equivalent or similar to what I've done above. All right, so let's do that. Okay, so let's start with print line A. So that will only print if a, let's define some a and b here. So this is not what you would need to write, but I'm just going to define some random integers a and b. Okay, so now I'm going to say if a not equal to b, then I'll print a. Okay, so far so good. So for b, there are two things that need to be true. A not equal to b, and also b less than 5. So if a not equal to b and b less than 5, that's when I would print b. All right. What about C? So for C, we know that A can't be equal to B, and that B can't be so this needs to be true, A not equal to B. This has to be false, because if it were true, we would have done this one and never even checked if it equals 8. So this must be true, this must be false, and this must be true. So we'll say if A not equal B, and it's not true that b less than 5, which I'm going to translate right away. So if it's not true that b is less than 5, then it must be true that b is larger than or equal to 5. And it must be true that b equals 8. Okay, so now if you're just plugging and chugging here, you just go on your merry way. But if you're thinking logically about what we're doing here, and IntelliJ is thinking about what needs to happen here. If b is larger than or equal to 5, if b is 8, it's automatically going to be true that b is larger than or equal to 5. So I don't actually need to do both those checks in this particular case. So I can simplify it just by saying b equals 8. But that's unique to this check. Remember, in the last example, we actually did explicitly need to test that the first if statement was not true. So what I'm trying to emphasize here is think about what you're doing all the time. You should never enter plug and chug mode when you're programming unless you're writing a basic for loop, in which case it's probably fine. Okay, so D. So in order to reach D, we know that the first if statement has to be true, A not equal to B, and we know that B has to be larger than or equal to 5 because the first if statement there can't be true. And we know that b can't be 8, b not equal to 8. And we know that b has to be equal to 2, all of those together. Again, let's think about it logically. If this is the set of things that would have to be true to reach D, I think the conclusion is that we can never reach D. Because if b is less than 5, we would execute b, and then we'd never reach down here. But if b is 2, then b has to be less than 5. So in order for this if statement to be true, an earlier if statement was already automatically true, which means we'll never print D. So this one let's leave out entirely. Okay, else. So E is going to happen if A not equal to B, and let's see, and if b is greater than or equal to 5. So what I'm going to do is I'm going to say each of these things has to be false. So b has to be larger than or equal to 5, and b can't be 8, and b can't be 2, but I'm going to leave that out because that would be superfluous. That would be extra, because b is already larger than 5. And so there is no additional and. That's it. So now I'll print E. And I have an additional E down here. So it prints E here, but it also prints E in the else statement. So I could do this. I could say if A equals B, then let's print E. The problem with having these on two separate lines is I might, well, I guess there is no problem because I'm not going to print E twice. But I think we could combine these into a single one by thinking about, well, I think actually I'm going to go back on what I was saying. I like them as two separate lines because I think the logic gets a little more convoluted if you try and combine them into a single line. All right, let's do the next one. This problem says, write a short program that will generate a random integer between 1 and 100 over and over again, displaying each number it generates until it generates a value between 10 and 15. All right, so let's start by generating a random number. Random number between, whoa, autocomplete, holy gazebo. Sometimes autocomplete goes horribly wrong. Math.random times 100, all right. Oh, I said inclusive. Oh, I said between 1 and 100 inclusive. Okay, so now it's between 1 and 100 inclusive. And I want to do this over and over again until it generates a certain value. So let's do this. Did I say a while? So to me, as long as you know that your thing needs to execute once, at least once, I would want to do a do while loop. So I'd want to say do the following, and then the while condition tests to see whether we should go back and do it again. So what did I say? Num is between 10 and 15. So 10 and 15. The reason that it doesn't recognize num, it says cannot resolve variable num, is I have defined the variable inside the do while block, but the while condition is actually technically outside the block because it's outside the curly braces. So the solution here is you have to actually declare your variable outside the block, and then you can assign it a value inside the block. Okay, so this, I think, would be a correct solution. We're going to generate a random number, and then, oh, I said do it until it's between 10 and 15. So, you know, it would be great if Java had a do until. It does not, but imagine, do this until this is true, and then stop. That would be great. The problem is we want to do while. So while this is not true, that's when we want to repeat. So an easy thing you could do is just negate the entire thing. We could say, while it's not true that this whole thing is happening, then keep going. And that would work perfectly fine. Let's think logically about what must be true if num is not between 10 and 15. If it's not between 10 and... So I'm showing you another solution now. What I've written right here would be perfectly fine. But another solution would be to simplify this. If num is not between 10 and 15, then one of two things are happening. Either it's less than 10, or it's larger than 15. Like, logically speaking, if it's not inside an interval, it has to be outside. And there's two ways it could be outside. It could be too small, or it could be too large. And if either one of these things is true, then I'd want to go back and do it all over again. So this is another solution. You might have thought, well, he said while loop. He didn't say do while loop. So now let's take this solution and make it into a regular while loop. A regular while loop, you do the test at the beginning. But the problem is I can't do the test at the beginning because I didn't actually give num a starting value. So let's do that. Here, I'll give num a starting random value, and then I'll say while that starting value isn't right, if it's too small or it's too big, then let's give it another value and repeat. So this also works. To my mind, this is slightly worse than the do while solution, but it also works just fine. Okay, let's do problem 8. Yes. So in problem 8, it says, how long would you have to roll 3 6-sided die until they all show 1 at the same time? All right. Problem 8. So let's roll 3 6-sided die repeatedly. So I'm going to call them D1, D2, D3. D1, I'm going to say int math.random times 6. This is not right, though, because you have to think all the time about what number, what's happening, what could happen. So math.random could be 0, and if I multiply 0 by 6, that would give me a die value of 0, but real dice can't ever be 0. Another thing that's wrong with this is math.random can't ever be as large as 1. It can be almost 1. It can be like 0.99999. But in order to get a die roll of 6, math.random would have to be 1, because that's the number you'd need to multiply by 6 in order to get an end result of 6. So the largest integer this will output is 5. So in summary, this will output a number between 0 and 5. I want it to output a number between 1 and 6, because that's what an ordinary dice would output. So let's just add 1. So now I've shifted my interval from 0 to 5. I've shifted that whole interval up by 1, so 0 to 5 becomes 1 to 6. All right, let's now do that same thing for die 2 and 3. And I want to do that over and over and over again until eventually, what did I say? They aren't all 1s. Keep looping as long as they aren't all 1s. Okay. So if I was going to do a do while loop, I would say do while. So what does it mean if they're all 1s? That means D1 equals 1 and D2 equals 1 and D3 equals 1. They're all 1. But I want to keep looping as long as that's not true. So let's think about, so you might think about this. Let's just make them all not true. The problem with this is saying all 3 of them can't be 1. But that's not what I want to say. I want to say keep going as long as any one of them isn't equal to 1. But this is saying keep going as long as all of them aren't equal to 1. So that's not really what I wanted to do. So let's go back. So this is saying each die has to be 1. I want to negate that entire statement. So I want to say it's not true that all 3 of them equal 1. Okay, so what does it mean to say that it's not true that all 3 of them are 1? What that must mean is that at least one of them isn't 1. And the way that you'd say at least one of them isn't 1 is we'll test to see if die 1 isn't equal to 1, or die 2 isn't equal to 1, or die 3 isn't equal to 1. So again, you can sort of think it through logically. But a nice starting spot is to take the condition that you don't want to be true and imagine negating the entire condition. And from a code perspective, you can just leave it here and that's fine. Okay, let's now turn this into a regular while loop by placing this at the beginning. And deleting that. Okay, and now we still have this problem because we needed to give them starting values. So this is a little bit gross, but it would work. I'm giving the 3 dice their starting values. I'm saying if at least one of them isn't 1. Wait, what did I want to say? Am I misreading this whole problem? A good piece of advice when you're programming is be clear about the problem in your mind when you start. How long would you have to roll until they all show 1? Yeah, that's right. So as long as at least one of them isn't 1, I want to keep going. And we'll only stop when they're all equal to 1. Okay, yeah, so I'm doing the right thing. So let me show you, an ever so slightly nicer thing to do. If you didn't know what the problem was, or you were a beginning programmer, which you might be, it would take a little beat. It would take a little moment to look at this and figure out what's happening. You'd be like, what's happening? I'm doing random number between something and something. I don't know. Conceptually, what's happening here is I'm just rolling a die. So imagine that we had a method called roll die down here that's going to return a random die roll. Oh. Ta-da. Oops. Okay, so all I've done is I've made the return value be what was on the right-hand side of all those equal signs. And so now I can replace each of these with roll die. And it might seem a little silly to do this because, like, you know, it was seemingly a lot of extra work to define this method. But look at how clean this is conceptually. I'm saying, like, oh, the value here is what I get when I roll the die. Roll the die, roll the die, you know, go, 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 go. So I think this is conceptually a lot simpler. And for a problem as small as this, it probably doesn't matter. But as you write larger and larger code, your code at some point will become so complex it will overwhelm you with its complexity. And the way to enable yourself to write larger programs is to do things like this, which will reduce the cognitive load in your own mind when you go back and read what your methods are supposed to be doing. This is easier to look at, it's easier to read, and that makes it easier to think about, which also means it's easier to debug if you would ever need to debug it. So this is going to be a big deal for us later on. The problem's not done yet, though. I wanted to count how many times it took, and then display how many times it took. So let's add a counter. I'll actually start the counter at 1 because I've already generated one set of rolls. And then here I'll say count plus plus, and then I'll display the counter. And actually, for the purposes of testing this, I'm actually going to display what the 3 die value were, and I'm going to display what the count value was. Okay, so let's run it now, and we can see what's going to happen. Okay, so we can see count going up, and we can definitely see, you know, we're not getting all ones anywhere here. At the end, we only displayed the count value, but we never actually displayed the all ones. Why is that? So let's imagine. So we display the count, and we display the die values. We roll the die. We increment count. Oh, it's because at the end I'm only displaying count. That's why. Okay, so let's just display this at the end. Okay. One more time. This seems on the face of it wrong because we should be seeing all ones. So what's happening here? Ah, I see the bug. Do you guys see the bug? You probably did. I neglected to say not equal. Okay, let's do it again. All right, great. So it took us 229 loops in order to finally get all ones. If I run it again, now I've got 221 to get all ones. That's interesting. 67. That was that was a lot fewer. Okay. Cool. Is there anything else I want to say about this? So if I didn't actually care about storing the values, I could greatly simplify all of this. Let's start with a counter, and here I'll say roll die. So this returns a die roll, and if it's not equal to 1, and then I do it again, and it's not equal to 1, and I do it again, and it's not equal to 1, I want to keep going. So this is me saying keep going as long as I don't get 3 in a row that are all ones. And so this is going to give me the same answer. This is simulating the same thing, and it's a lot shorter. I'm just not bothering to store the results of my die rolls. I'm just using them in my test here. And so here we can see what our values are. So 196. And like here, it's a little bit hard to check to see if it actually worked. And so that's why I did it the way that I did it the first time. When you actually store the values, then you can test to make sure that it actually made sense and worked. But this would be an equivalent simulation. Oh, and that's the end. Okay, wow, this was a really long one. Okay, it's because it was too much yapping. All right, come back for the next one, and I hope that these have been helpful.